inequalities on the same coordinate plane to find a maximum or minimum function in two variables is called linear programming. So all we're really doing today is graphing or just inequalities and finding the maximum of them. Okay? The intersection of a system of inequalities represents all combinations of ordered pairs that satisfy each of the inequalities. The inequalities are called constraints. And the intersection of the graphs is called the feasible region. When a system of inequalities produces a convex polygonal region as a solution, the maximum or minimum value of a related function will recur at a vertex of the region. Okay? So we're going to graph all these inequalities. It's going to create some sort of shape. Sometimes it's a nice triangle. Sometimes it's a goofy looking quadrilateral, but it will make some sort of polygonal shape. Okay? That shape, all the ordered pairs within that shape are going to be possible combinations of solutions that work with every single one of the inequalities you graph. Okay? And then we are going to look at the vertices of that, so the points of that region, to figure out our maximum or minimum. Okay? When the graph of a system of constraints is a polynomial region, the region is said to be bounded. We have a bounded region when it's kind of inside. The notation f of x, y is used to represent a function with two variables. It is read as f of x and y. Similar to function notation, but we're just dealing with two variables rather than one. Okay? Similar stuff as function notation. Stuff we're just dealing with. Questions of it. Okay. So let's look at our first one. So our first steps, all we're going to do is just graph these inequalities. Okay? And just like graphing a normal line, it needs to be in this similar form, a little different because it's not equal sign. Still needs to look something like this. Y needs to be by itself. So if we look at this first equation, how are we going to get y by itself? I'm going to write it off to the side. What do we have to do with x to get y by itself? Subtract x. Subtract x over. Subtract x over. So I get y is greater than or equal to negative x plus 2. There's one of our equations. Let's go ahead and graph it. Right? Graph it just like a normal line. Know the inequality symbol is there. You originally graph it just like a normal line. So when we graph it, where are we starting at? We're 2 on our y-axis. And then what's our slope? Down 1 over 1. Okay, our slope, because there's a negative sign in front of x, is negative 1 over 1. And then our y-intercept, the number of y itself, is 2. Just follow that slope. Make sure you go all the way across on your paper. I know it's a pain. But go all the way across. You get nice, neat lines. And remember, when graphing inequalities, you always have to look and see, is there a line underneath, or is there no line underneath? With this, and 99.9% of the time, you're going to deal with a line underneath. So you're just going to connect your points with a solid line. So really, we're just graphing this how you would graph a normal line. Okay? And then you shade, right? But look how many inequalities we have to graph. Okay? There could be a lot of shading, and you guys only have pencil, and it's kind of hard to see what shadings intersect where. So what I like to do is just graph all my lines, and then look for the shape that's made up by all the lines, and then shade in that shape. Okay? So we're going to hold off on shading right now. And then we're going to take a look at our second line. We have 4y is less than or equal to 8. Well, how are we going to get y by itself? What do we have to do with the 4? Divide it. So divide by 4. Divide everything by 4. So we get y is less than or equal to. Technically, what's in front of this x? 1. So we're just going to write it as 1/4 x. 1 can't go into 4, so we're still leave it as 1/4 x. And then what is 8 divided by 4? Okay. Here's our second line. And go ahead and graph that. When we graph it, what's our slope? 1/4. And then what's our b?
2.
Okay, so again, we're going to start at 2 and follow your slope. Up 1, right 4. Up 1, right 1, 2, 3, 4. And then up 1, right 4, go opposite direction, down 1, 1, 2, 3, left 4. And you're going to go all the way across your paper so you get nice and straight lines. And then we have this third line. What do we have to do with the 2? To get y by itself. Fine. Cancels, we get y is greater than or equal to 3/2, can't simplify. Minus 3. There is our third line. We're going to go ahead and graph it. Again, what's our m of that third line? What's our slope? 3/2. Good. And then what is our b? We start at -3 and go up 3, 1, 2, 3 over 2. 1, 2, 1, 2, 3 over 2. Up 1, 2, 3 over 2. And then go down 3, 1, 2, 3 over 2. Go the opposite direction. And so you want to make sure y is by itself in all 3 equations, and then you graph the lines like you would normally graph a 9. I know there's an inequality, but there's a line underneath it, so you just use nice solid lines. Okay? Save the shading for the end, because it can be confusing when you have a bunch of shading going on, because you're dealing with a lot of lines. Okay? If we look, you see this triangle in the middle, green line, red line, blue line. We have a triangle that's made up of all 3 lines. That's the reason you're going to shade. So take your pencil, I'm going to use a highlighter on here, and you're just going to shade in that region. Right there. The shape that's made by all 3 lines, that's what you're going to shade in. Okay? That is what we call our feasible region. That's where all your possible order pairs that will work are. Okay? So we graphed the system of inequalities. Now we want to name the corners of the vertices of the feasible region. HKN, you're just going to name the vertices of this triangle we just made. Okay? So here, vertice is 0, 2. Then we have a vertex of 2, 0. And then we have a vertex of 4, 3. Some of you might be thinking, well, why didn't we graph this line? Okay? Why didn't we graph this f of x of y? We saved that for the very end. Okay? So you only graph the lines that are inequalities, so we would only graph these. And this guy we're saving to the very end to figure out the maximum and minimum. So the one written in function notation, you don't graph it. We use that to find the maximum and minimum value. Okay? And this is where it's going to come into play. We're going to take these vertices and plug it into this function. Alright? So if we take a look at the point 0, 2, we're plugging 0 in for x, and we're plugging 2 in for y. So we take 0 and plug it in for x, we just get 0 plus 3 times 2. You're literally just taking that point and you're plugging it into that function. And then what do we get when we do 0 plus 3 times 2? 6. Right? Then you repeat it with the other point. So we're going to take 2, 0 and plug it in. So we're plugging 2 in for x and 0 in for y. And what do we get when we do 2 plus 3 times 0? What's 3 times 0? 0. 2 plus 0 is 2. Okay. Then take that third point, plug it in. So we are plugging 4 in for x and 3 in for y. So we get 4 plus 3 times 2. And what do we get when we do 4 plus 3 times 2? 2. We get 2. We are going to use this information to state the maximum and minimum values. Well, you know it's a maximum value. Which one gave us the biggest number? Which point?
The last problem that we did, wouldn't you plug in like 3 in for y, not 2?
Oh, thank you. Very good. Okay, when we plug 3 in, what do we get? 13. There we go. Which one of these gave us the biggest number? The 0, 2, 2, 0, or 4, 3? 4, 3. So we would say there is a max of 13, because that's the number we got, at the point 4, 3. If we look, which one gave us the smallest number? Yeah, the point 2, 0. So we would say there's a min of, what was the number they gave us? 2. So there's a min of 2 at the point 2, 0. So our maximum value is 13 at this point, and then the minimum value of 2 at that point. Done. So these are literally the steps you're going to take when doing one of these problems. You graph the inequalities, then you want to shade in that region that's formed by all the lines you graph. You pick the vertices of that shape. You take those vertices, plug it into the function notation, the equation that has a function notation, and then you look at the numbers you got. The one that gave you the biggest number is your max. The one that gave you the littlest number is your min. Okay? Questions over that. We'll do one more together and get time to practice. Again, graph. This is a little different because we don't have those normal equations we graph. We just have y is greater than 2. But you graph it just as if it said y equals 2. So all you have to do is go to where y is 2, go to your y-axis, and then put a point, and you just draw a nice straight horizontal line. You want to make a note. When you have it just y and a number, you know you're making a horizontal line. You do a vertical line, and you're just going through the whole entire y-axis. Here, this is a little different because you have 1 is less than or equal to x, which is less than or equal to 5. That's like breaking this up into 2 different ones. Right? That's like saying 1 is less than x, and x is less than or equal to 5. It's like breaking it up into 2 different inequalities. You graph it really similar to we graph the other one, except instead of going to work y is 1, we're going to work x is 1. So it's 1. What kind of line do you think you're going to draw there? If we did a horizontal with y, what are we going to do with x? Vertical. We draw a nice vertical line. Okay. And then you do the same thing with 5. You go to where x is 5, put a point, and draw a nice vertical line. Is a nice normal one. You don't have to worry about solving for anything if y is already by itself. So what's our slope in this one? What is it?
1 over 1.
Yeah, 1 over 1. Nothing in front of the x is just 1 over 1. And then our b is that number all by itself, so it's 3. We start at 3. Go up 1 over 1. All the way across. We go up 1 over 1, you can go in the opposite direction, you can go down 1 over 1. And you notice there's more than one shape, right? There's this little triangle right here. Right? There's this triangle, and there's this kind of goofy shape right here. Here's the thing, the shape that you shade in has to be made by all of the lines you graph. You notice with this triangle, it's made by the red line, it's made by the blue line, it's made by the green line. But is that triangle made up of that purple line? The purple line touching that triangle? No. So the triangle is not going to be the region you shade. Okay? We have to shade in this because it's all 4 lines make up that shape. So that's what we're going to shade in. Sometimes you get more than one shape. If that happens, you have to make sure, well, all 4 lines have to be touching that shape. And if you notice, you graphed 1, 2, 3, 4 lines. So the figure you're going to be shading is going to be 4-sided. Okay? On the previous one, we only graphed 1, 2, 3 lines, and our figure was a triangle with a 3-sided shape. Keep that in mind. So we graphed our system. Now we have to make state the vertices on the shape. Someone give me one of the vertices.
1, 2.
Good. 1, 2. What's another vertice?
5 and
5 and what?
2.
5 and 2. What's another vertice? Tell me. Another one. Joanna, what's another vertice?
5 and 2.
We have 5 and 2, 5 and
8.
good. And what's our last one? What is it? Okay. Graph your inequalities. Write down the coordinates that make up that shape. And then what do we have to do with these points? Plug them in. Plug them into this guy. And don't graph this guy. We just use it for this step C. You take all these points and plug it in. So if we look at 1, 2, we're plugging in 1 for x and 2 for y. What do we get when we plug those numbers in? What's 3 times 1 minus 2 times 2? 3 times 1 equals 2 times 2. What? There you go. Try the next point. We're going to plug in 5, 2. For this one, we're going to do 5, 2. We're plugging 5 in for x and 2 in for y. What do we get when we do 3 times 5 minus 2 times 2? 11. Do the same thing for the next point. We're going to plug in 5 in for x and 8 in for y. What do you get? What is it? Plug in this last one. We're going to plug 1 in for x and 4 in for y. 3 times 1 and 2 times 4. Okay. 3 times 1 minus 2 times 4 is -5. So you have to plug in all points. All of them. Right? Don't just plug in a couple and think you have the answer. You have to plug in every single one of the points. Right? And then using that information after you plug it in, which value is our maximum? What's the highest number? 11. So we have a max of 11 at 0.52. What's our minimum value? 5. Good. So we say we have a min of -5 at 0.14 because that's what gave us that value. And we are done. Questions over that? Yes.
If you didn't have the -5, what would you write if you just had like two of the same minimum values?
Good question. You would just say there's a min of -1 at both. They both give you the minimum. Good question. Any other questions?